This is the EdExcel A-Level Maths Paper 2 from the sample papers, and in this paper we'll be taking a look at the pure maths section. Question number 1. We're given f of x equals 2x cubed minus 5x squared plus ax plus a. We're given x plus 2 is a factor of f of x, and with this we have to find the value of the constant a. Well, if x plus 2 is a factor of f of x, we can say from here then, x plus 2 equals 0, and therefore x is equal to minus 2. And so, using the factor theorem, f of minus 2 is equal to 0. So, we've got 2 lots of minus 2 cubed minus 5 lots of minus 2 squared plus a lots of minus 2 plus a. This is all equal to 0. We've got minus 36 minus 2a plus a equaling 0, and so we can conclude a is equal to negative 36, and knowing what the value of a is, we can therefore conclude f of x is equal to x cubed minus 5x squared minus 36x minus 36. Question number 2. Some A-level students were given the following question. We have to solve for theta being in between 90 degrees and 90 degrees the equation cos theta equals 2 sin theta. We've got the attempts of the two students shown below, and for part A we have to identify an error made by student A. Well, we've got cos theta equals 2 sin theta. On the right hand side we end up with a 2, and to get that 2, student here has divided the right hand side by sin theta, and so we'd also have to divide the left hand side by sin theta. But the problem is cos theta over sin theta is not tan theta. So when we come to identify the error made by student A, well, they used cos theta over sin theta being equivalent to tan theta. It should be sin theta over cos theta being equivalent to tan theta. Now, student B gives theta to equal minus 26.6 degrees as one of the answers to cos theta equals to sin theta. We have to explain why this answer is incorrect and explain how this incorrect answer arose. Well, if they got minus 26.6 as one of the solutions, let's see if that solution is correct. When theta equals minus 26.6 degrees, on the left hand side of our equation we have the cosine of minus 26.6 degrees, and if we work out the numerical value of this, the cosine of minus 26.6, that's equal to 0.894, etc. And on the right hand side, we have 2 times by the sine of minus 26.6 degrees. So if I work out what this is, 2 times by the sine of minus 26.6 degrees, that's equal to minus 0.895, etc. And because the left hand side doesn't equal the right hand side, we've got an incorrect solution. Now let's think about how this incorrect answer arose. Well, on line 2, the squared cos theta equals 2 sine theta, giving cos squared theta equals 4 sine squared theta, and eventually this led to an incorrect solution. Question number 3. We are given that y equals x lots of 2x plus 1 to the power of 4, and with this we have to show that dy over dx is equal to 2x plus 1 to the n lots of ax plus b, where n, a and b are constants to be found. We've got two functions which are being multiplied by each other, and so here we'd have to use the product rule. We've got u, which is equal to x. U dash is therefore equal to 1. We've got v, which is equal to 2x plus 1 to the power of 4. And v dash, using the chain rule, we multiply by the power, and then we subtract 1 from the power. We then multiply by the derivative of what's inside the bracket. We multiply by 2. And so v dash is equal to 8 lots of 2x plus 1 cubed. And so if we find out what dy over dx is, this is equal to v times by u dash plus u times by v dash we need to now tidy all this up. So we've got 2x plus 1 to the power of 4 plus 8x lots of 2x plus 1 cubed. And if I factorize out a 2x plus 1 to the power of 3, because that's the highest common factor, inside of our bracket we would have 2x plus 1 plus 8x. And so, simplifying this even further, we've got 2x plus 1 cubed multiplied by, well, 2x plus 8x is 10x. And then we've got the plus 1. And so this is our final answer. Question number 4, we're given f of x is equal to e to the power of x, where x is a real number, and g of x is equal to 3 times by the natural log of x, where x is greater than 0 and x is a real number. For part A, we have to find an expression for g of f of x, simplifying your answer. Well, g of f of x would have to substitute in f of x into g. So we replace the x with e to the power of x. So we end up with 3 times by the natural log of e to the power of x. And if we use the power law of logs, bringing this power down, we end up with 3x times by the natural log of e, which is quite simply 3x. And now for part B, we have to show that there is only one real value for x for which g of f of x is equal to f of g of x. Well, what we'll do for part B is we'll find out what f of g of x is. And if we work out what this is, we replace the x with 3 times by the natural log of x. So we have e to the power of 3 times by the natural log of x. If we use the power law, we've got e to the power of the natural log of x cubed, which is quite simply x cubed. And so if we have g of f of x equaling f of g of x, we have 3x equaling x cubed. So x cubed minus 3x is equal to 0. So we've got x lots of x squared minus 3 equals 0. And so if we solve for this, either x is equal to 0, or if x squared minus 3 equals 0, x is equal to plus minus the square root of 3. Now, because x is greater than 0, we were told that in the question here, what we can conclude from here then is x equals square root of 3 would be the only solution. Question number 5. The mass m grams of a radioactive substance 2 years after first being observed is modelled by the equation m equals 25e to the minus 0.05t. According to the model, we have to find the mass of the radioactive substance 6 months after it was first observed. Well, what you'd find is t is given in years, and we are finding the mass of the radioactive substance 6 months after it was first observed. And so, if we have our model given here, if we're considering 6 months after it was observed, this would imply t equals 0.5. In other words, we've got half a year, which is 6 months. And so when t is equal to 0.5, m is equal to 25 e to the power of minus 0.05 times by 0.5. And if we work out the value of this to 3 significant figures, we've got 25 e to the power of minus 0.05 times 0.5. It turns out we get 24.4 grams to 3 significant figures. And now we have to show that dm over dt is equal to km, where k is a constant. Well, what we'd have to do here for part B, when I differentiate an e I multiply by the derivative of the power. So, to work out what dm over dt is, this is equal to minus 0.05 multiplied by 25 e to the power of minus 0.05 t. And what we end up with here is minus 0.05 multiplied by m. The result we see here is what m is. And so, this minus 0.05 is the value of k. So k is equal to minus 0.05. Question number 6. We have to complete the table below. The first one has been done for you. For each statement, you must state if it is always true, sometimes true, or never true, giving a reason in each case. Well, let's take a look at the first one. We've got the quadratic equation ax squared plus bx plus c equals 0, where a doesn't equal 0. This has two real roots. Well, this is sometimes true because if it's got only two real roots, then the discriminant b squared minus 4ac is greater than 0. When the discriminant b squared minus 4ac is equal to 0, it has one real root, and when b squared minus 4ac is less than 0, it's got 0 real roots. So let's take a look at the first one. When a real value of x is substituted into x squared minus 6x plus 10, the result is always positive. Well, if we have x squared minus 6x plus 10, we can complete the square. So I've got x minus 3 all squared, and then we've got minus 9 plus 10, which is plus 1. Now, because x minus 3 all squared will always be greater or equal to 0, and because 1 is definitely greater than 0, we can therefore conclude that x minus 3 all squared plus 1 is greater than 0. And it follows then that x squared minus 6x plus 10 will always be greater than 0. So this is always true. What about the next one? If ax is greater than b, then b is greater than x is greater than b over a. Well, if over here a is greater than 0, and we've also got ax being greater than b, then if I divide through by a, because a is positive, x is greater than b over a. Now, let's suppose now a is negative and ax plus ax is greater than b. Now in this case, x will be less than b over a. We're dividing by a negative number, so the direction of the inequality sign changes. So this is sometimes true. And now for the next one, the difference between consecutive square numbers is odd. Well, if I have consecutive numbers n plus 1 and n, the difference between the squares of those will be n plus 1 all squared minus n squared, which is the same as n squared plus 2n plus 1 minus n squared, and tidying this up we get 2n plus 1. And this result here, 2 times by a number is even, plus 1 makes it odd, so this is odd. And it's odd for n belonging to a set of positive numbers, positive integers. Question number 7. For part A, we have to use the binomial expansion in ascending powers of x to show that the square root of 4 minus x is equal to 2 minus a quarter x plus kx squared plus higher order terms where k is a rational constant to be found. Well, for part A, if I've got 4 minus x square rooted, I need to use the binomial expansion. Now, if I go to the formula book, for the binomial expansion, we've got 1 plus something to the n. And so we want to rewrite this so we've got 1 plus something. Now, the way I can do that is by factorizing out a 4. So I would have 4 lots of 1 minus 1 quarter x, and all of this is square rooted. And using the laws of surds, this is the same as the square root of 4 multiplied by 1 minus 1 quarter x square rooted. Now, technically speaking, we don't actually need these brackets here. Okay? So we need to simplify all this, and it turns out when we do simplify it, square root of 4 is 2, and then here we've got 1 minus 1 quarter x to the power of 1/2. So now we need to find out the binomial expansion for this, which is given by this result here. So, if I work out what this is, we've got 2, and then we've got 1 for our first term. Next term is nx, so that will be 1/2 multiplied by minus a quarter x, and then we divide this by 1 factorial, and then for the next term we've got 1/2 lots of minus 1/2 lots of minus 1 quarter x squared, and then we will divide this by 2 factorial, and then we've got higher order terms. And so if we tidy this up even further, we've got 2 lots of 1 minus x over 8 minus x squared over 128 plus higher order terms. And if I multiply the 2 into the bracket, we've got 2 minus x over 4 minus x squared over 64 plus higher order terms. Now, for the next part of the question, a student attempts to substitute x equals 1 into both sides of the equation to find an approximate value for root 3. We have to state, giving a reason, if the expansion is valid for this value of x. Well, for part B, if we take a look at our expansion, we would have 4 minus x equals 0, so therefore x is equal to 4. And therefore, to find out the range of values for which the expansion is valid for, it will be valid for the mod of x being less than 4. There is another way we could have figured that out. If I take a look at the 1 minus 1/4 x, I could have done this by stating that I've got the mod of minus 1/4 x being less than 1, in which case the mod of x is less than 4. So there are two ways of doing it. And so therefore we can conclude that x equals 1 can be used. Question number 8. We've got figure 1 which shows a rectangle ABCD, that's what we see here, and the point A lies on the y-axis and the points B and D lie on the x-axis as we see in figure 1. Given that the straight line through the points A and B has equation 5y plus 2x equals 10, for part A we have to show that the straight line through the points A and D has equation 2y minus 5x equals 4. Well, what we can do to begin with is find out the point A and find out the point B. We can also find the gradient of AB and use the fact that AD is perpendicular to AB to find the gradient of AD and then find the equation of that line. So if I consider the line, part A, AB, so far we have 5y plus 2x equals 10. Now, if I rearrange this so it's written in the form y equals mx plus c, spotting the gradient would then be quite easy. So, what this is equivalent to is y equals minus 2 over 5 x plus 2. So straight away we can spot that the gradient m is equal to minus 2 fifths. Now when x is equal to 0, we can find out the corresponding y value. We've got 5y equals 10, so y is equal to 2. And so therefore the point A would have coordinates 0, 2. Let's add this to the diagram. We have the point A, 0, 2. Now, when y is equal to 0, 2x equals 10, x is equal to 5. And so the point B has coordinates 5, 0. So the point B has coordinates 5, 0. Now we can find out the line AD, we can find out the gradient of AD. We know it passes through the point 0, 2. So if we consider the line AD, the first thing we can do is find out the gradient. So the gradient is equal to the negative reciprocal of minus 2 fifths, which is 5 over 2. And we know that it passes through the point 0, 2. So we've got y equals 5 over 2 x plus 2. And we can rearrange this to say that the equation of the line AD, that will be given by 2y minus 5x equals 4. Now, when y is equal to 0, we've got minus 5x equals 4. So therefore x is equal to minus 4/5. How does this help us? Well, what we can now do is find out the point D. The point D then would have coordinates minus 4/5, 0. So I've got minus 4/5, 0. Now, when we come to find out the area of the rectangle for part B, I need the length of AD and I need the length of AB. So, the length AB, that will equal, well, I've got 5 take away 0 squared plus 0 take away 2 squared, and then I square root this. So the length of AB will equal square root of 29. And if I find out the length of AD, length of AD will equal minus 4/5 minus 0 squared plus 0 minus 2 squared, and all of this is square rooted, and it turns out we get 2/5 over, rather 2/5 lots of the square root of 29. And so therefore, when we come to find the area, that's quite simply the square root of 29 multiplied by 2/5 times by the square root of 29. And it turns out we get 29 times 2/5, which is equal to 58 over 5 units squared. Question number 9. We're given that a is a constant and the integral of 3 times square root x plus a with respect to x in between 1 and 4 is equal to 2a squared. We have to show that there are exactly 2 possible values for a. Well, I've got the integral between 1 and 4 of, well, to make life easier for myself, I'm going to rewrite this as 3x to the power of 1/2 plus a. And this is equal to 2a squared. Now, if I work out what the left-hand side is in terms of a, well, integrating 3x to the power of 1/2, I end up with 2x to the power of 3 over 2. And then I add on the integral of a, which is quite simply ax. And I will evaluate this in between 1 and 4. And the answer to all this is 2a squared. So if I substitute in for my upper limit, I've got 2 lots of 4 to the power of 3 over 2 plus a lots of 4 minus 2 lots of 1 to the power of 3 over 2 plus a lots of 1. This is equal to 2a squared. I've got 2 times by 8, which is 16, plus 4a minus 2 plus a. And this is equal to 2a squared. And so if I rearrange, we've got 2a squared minus 3a minus 14 equals 0. Factorising, 2a minus 7 lots of a plus 2 equals 0. from which we can conclude a is either equal to 7 over 2 or minus 2. Question number 10. In a geometric series, the common ratio is r and the sum to n terms is Sn. We're given the sum to infinity is equal to 8/7 lots of the sum of the first 6 terms, and we have to show that r is equal to plus minus 1 over square root k, where k is an integer to be found. Well, how would I find out the sum to infinity? Well, the sum to infinity is given by this, and the sum of the first n terms is given by this. Well, of course, we've got the first 6 terms, so we're going to replace n with 6. So if we do that, we have a over 1 minus r equals 8 over 7 multiplied by a lots of 1 minus r to the power of 6 divided by 1 minus r. Now, happily for us, the 1 minus r's cancel on both sides, so do the a's. So we are left with, if I multiply through by 7, we've got 7 equals 8 lots of 1 minus r to the power of 6. We need to find out what r is. Well, if I rearrange, I would have r to the power of 6 equals 1 over 8. And what I need to do is find out the 6th root of 1/8. Now, let's just rewrite that. I need to find out the 6th root of 1 over 8. Now, if I take a look at the question, here I've got the square root, not the 6th root, so we need to adapt. So, what this is the same as is taking 1/8 and finding and raising this to the power of 1 over 6. So, we need to simplify this and somehow get square roots. Well, what I can do is raise 1/8 to the power of 1/3 and then raise this to the power of 1/2. And the reason I want to do this, raising something to the power of 1/2 is the same as square rooting, and using the laws of indices, 1/3 times by 1/2 is the 6th. Now, 1/8 to the 3rd is 1/2, so I've got 1/2 to the power of 1/2, which is the same as finding the square root of 1/2. Don't forget we've got plus minus, and technically speaking we should have plus minus throughout because we've got a positive root we're taking. Okay, so let's just adapt this, and therefore we end up with plus minus 1 over the square root of 2. So therefore k is equal to 2. Question number 11. We've got figure 2, which shows a sketch of part of the graph y equals f of x, where f of x is equal to 2 lots of 3 minus x modded plus 5, where x is greater or equal to 0. And for part A, we have to state the range of f. Well, the minimum point over here will correspond to the value of 5. And that's just the vertex. So for part A, f of x is greater or equal to 5. And now for part B, we have to solve the equation f of x equals 1/2 x plus 30. So, for part B, I've got two lots of the mod of 3 minus x equaling 1/2 x plus 30. Now, if I rearrange, I can see that the mod of 3 minus x is equal to 1/4 x plus 25 over 2. And rather, I just made a mistake here. That's because I need to add on 5 here. So, we now replace the modular symbols with plus minus. So I've got plus minus 3 minus x equaling 1/4 x plus 25 over 2. So if I consider the positive, I've got 3 minus x equals 1/4 x plus 25 over 2. And if I solve for x here, x would equal minus 38 over 5. And if I consider the negative, I would have negative 3 minus x, which is x minus 3. And this is equal to 1/4 x plus 25 over 2. And so what you'd find here then is x is equal to 62 over 3. And we also know x is greater or equal to 0, so as x is greater or equal to 0, x equals 62 over 3 is the only solution. And now for the next part of the question, given that the equation f of x equals k, where k is a constant, has two distinct roots, we have to state the set of possible values for k. Well, we've got two distinct roots, and what we'll do to begin with is we'll find out this point over here. So, when x is 0, we've got two lots of 3 plus 5, which is 11. And what we can also see is the vertex here will be at 3, 5. Now what's happening is we've got two distinct solutions. So if we've got two distinct solutions, that means if I extend this grey line, I'd have two solutions here and here. But if I have a line here, I'd only get one solution. So I want everything above this vertex, but also less than or equal to 11. So in between these values is where I'd get two distinct solutions. So hopefully just that bit would make sense. And so therefore, for part C, quite simply, we have 5, which is less than k, which is less than or equal to 11, where y equals k is a horizontal line. Question number 12. For part A, we have to solve the equation 3 sine squared x plus sine x plus 8 equals 9 cos squared x, where x is in between minus 180 and 180, and we have to give our solutions to two decimal places. So what we'll do for part A, let's just copy out the equation. We've got 3 sine squared x plus sine x plus 8 equals 9 cos squared x. And what I'm going to do is replace cos squared with 1 minus sine squared x. That will make sure I get everything in terms of sine. And if I do that, I've got 3 sine squared x plus sine x plus 8 equals 9 lots of 1 minus sine squared x. So I've got 3 sine squared x plus sine x plus 8 equals 9 minus 9 sine squared x. I've got a quadratic here, and I need to rearrange so everything's on one side. If I do that, I get 12 sine squared x plus sine x minus 1 equals 0. So I've got 4 sine x minus 1 lots of 3 sine x plus 1 equals 0. So sine x is either equal to 1 over 4 and minus 1 over 3. So let's find out what x is. If I find the inverse sine of 1 over 4, I get 14.48. This is to 2 decimal place. And if I do 180 minus this, I get 165.52 degrees. Now if I take away 360, because the graph repeats every 360, I get something smaller than 180, so I can reject that value. Now if I do the inverse sine of minus 1/3, I get minus 19.47 degrees. And if I find out the value before this, what I need to do 180 minus this, and then take away 360 from this. So I get minus 160.53 degrees. So these are my solutions given to 2 decimal places. And then we have to find the smallest possible solution, the smallest positive solution to the equation 3 sine squared of 2 theta minus 30 plus sine of 2 theta minus 30 plus 8 equals 9 cos squared of 2 theta minus 30, giving an answer to 2 decimal places. Well, what you can see here is the x has been replaced with 2 theta minus 30. So what I'm going to do is replace the x with 2 theta minus 30. So with x equaling 2 theta minus 30, well, what would give us the smallest positive value? Well, I need to set the 2 theta minus 30 equal to the minus 19.47, etc. This will give the smallest possible value. And the reason for that is if I add 30 to this, I get something positive, and then dividing it by 2, I get something positive, but this value here, I'd get a smaller positive value. So if I find out what theta is from here, it turns out we get theta equals 5.26 degrees to 2 decimal places. This is the smallest positive value of theta. Question number 13, for part A, we have to express 10 cos theta minus 3 sin theta in the form r cos of theta plus alpha, where r is greater than 0 and theta and alpha is in between 0 and 90 degrees. You have to give the exact value of r and give the value of alpha in degrees to 2 decimal places. For part A, we've got 10 cos theta minus 3 sin theta. What will this equal? Well, if I go to the formula book, underneath the trigonometry section, I need to use one of these identities. Which one would I use? Well, we've got cos of a plus b. It's in that form. So, we need to use this result here. If I use the plus, that means I'd have to use the minus. So, this is the same as r cos theta times by cos alpha, and then I subtract r sine theta r sine alpha. And if I compare the terms involving a cos theta, you can see on the left hand side I've got 10 of them, and on the right hand side I've got r cos alpha of them. And if I compare the sine thetas, then I've got 3 on the left hand side, and on the right hand side I have r sine alpha of them. The minuses cancel on both sides, by the way. To find out what alpha is, I can divide this equation by this equation, and if I do that, r sine alpha divided by r cos alpha, that's just tan alpha, and then we've got 3 divided by 10. So we can find out what alpha is. We've got the inverse tangent of 3/10, and it turns out we get 16.69, etc. To 2 decimal places, let's just call it 16.70. I'm going to store this into A. Now r is quite straightforward to find. We've got 10 squared plus 3 squared and then we square root this. So it turns out we get square root of 109. So when we come to express this result in the required form, we can therefore conclude that 10 cos theta minus 3 sine theta, that will equal the square root of 109 times by the cosine of theta plus 16.70. Now for the first part of part B, well, let's read the question beforehand. The height above the ground h meters of a passenger on a Ferris wheel t minutes after the wheel starts turning is modelled by the equation h equals a minus 10 cos of att degrees plus 3 sine of att degrees, where a is a constant. And figure 3 shows the graph of h against t for 2 complete cycles of the wheel, and given that the initial height of the passenger above the ground is 1 meter, we have to find a complete equation for the model and hence find the maximum height of the passenger above the ground. So, we're given that the initial height is 1 meter above the ground. So what that means, when t equals 0, h equals 1. So when t equals 0, h equals 1, and what we need to do is find out the value of a. So if I use the equation given here, we're going to have the cosine of 0 and the sine of 0 over there. So I've got 1 equals a minus 10 times by the cosine of 0 plus 3 times by the sine of 0. Now the sine of 0 is 0, so I've got 1 equals a minus 10 because cos of 0 is 1, in which case you can see a is equal to 11. And knowing that a is equal to 11, we can conclude h equals 11 minus 10 cos of att plus 3 sine of 80t. Now, I'm going to use the answer I found in part A to rewrite the result. So I can also rewrite this as h equals 11 minus square root 109 times by the cosine of, well, instead of having an 80t, well, instead of having a theta, I've got 80t instead. And then I add on 16.70. And now what I need to do is find the maximum height of the passenger above the ground. Well, I've got a negative cosine. So what I need to do, if I think about the graph of cos, I know the graph of cos looks like this. So this is cos x. So negative cos x would look like this. Okay. So what we can say from here then is, for the next part of the question, we can say we've got a maximum when cos of 80t plus 16.70 is equal to minus 1. So I'm going to replace this over here with minus 1. So h is equal to 11 minus 109 square rooted times minus 1. And if I work out what this is, we'll give our answer to 2 decimal places. I've got 11 minus the square root of 109 times minus 1. As a decimal, I get 21.4 meters, given to 3 significant figures. Now this maximum occurs at 180 degrees normally. So now when we come to find the time taken to the nearest extent for the passenger to reach the maximum height on the second cycle, what we need to realize is, if I think about the graph, okay, let's just think about the graph of cos. Graph of cos looks like that. Here's 180, where we got the minus 1. And then because it repeats every 360, the next value here will be 540. So what we're going to do is set the cosine of 80t plus 16.70 equal to the cosine of 540. And this is where the next maximum occurs. So I've got 80t plus 16.70, etc. equals 540. So now I need to find out what t is. So I've got 540, take away that value, and if I divide this by 80, I get 6.48, etc. So therefore I've got 6 minutes, and take away 6, and then times by 60, I get 20. So here I get 28 seconds. Let's just make sure I've got this correct. So I've got 540, take away that value, and then if I divide this by 80, I get 6.54 rather. So here I get 32 seconds. Question number 14. A company decides to manufacture a soft drinks can with a capacity of 500 milliliters. The company models the can in the shape of a right circular cylinder with radius r centimeters and height h centimeters. In the model, they assume that this can be made from a metal of negligible thickness. For part A, we have to prove that the total surface area, s centimeters squared, of the can is given by s equals 2 pi r squared plus 100 over r. Well, what we'll do for part A is let's just draw a quick cylinder to help visualize the problem. Well, here is a cylinder, and let's just mark on here. We've got the radius, and here we've got the height h. Now the volume v, that's equal to pi r squared h, and we are told that the volume is 500. So we can rearrange for h to say that h is equal to 500 over pi r squared. We'll call this equation 1, just in case we need it later on. Now the surface area S, that's equal to, well, I've got the top circle and the bottom circle, so that's going to be 2 lots of pi r squared. And then I need to add on 2 pi r h, which is the curved bit around the edge. And if I call this equation 2, I will substitute 1 into 2. So I have S equals 2 pi r squared plus 2 pi r times by 500 over pi r squared. And if I tidy all of this up, I can conclude S is equal to 2 pi r squared. Well, here 2 times by 500 is 1000. The pi's cancel, and r over r squared is quite simply r. So this is what I end up with. And now for part B, given that r can vary, we have to find the dimensions of a can that has minimum surface area. Well, minimum surface area suggests to us we need to find out what ds over dr is and then set it equal to 0. So if I differentiate for part B, ds over dr equals 4 pi r minus 1000 over r squared. And now what I need to do is set this equal to 0. So, multiplying through by r squared, we've got r cubed, and then if I rearrange, that's equal to 1000 over 4 pi. In which case you can see r is equal to 1000 over 4 pi, and then we take the cube root of this. So that's what r is. And if I find out the decimal equivalent, I've got the cube root of 1000 over 4 pi, which is 4.30, given to 3 significant figures. So now to find out, if we go back to the question, we need to find the dimensions of a can that has a minimum surface area. So we know what the radius is, that gives the minimum surface area. We also need to find out the corresponding h value. So the corresponding h value, well, we know h is equal to 500 over pi r squared. So we divide this by pi lots of 4.30, etc. squared. So if I work this out, I've got 500 over pi lots of this squared, which is 8.60, etc. to 3 significant figures, 8.60, and don't forget the units, we've got centimetres. Now for part C, with reference to the shape of the can, we have to suggest a reason why the company may choose not to manufacture a can with a minimum surface area. Well, possibly a radius of 8.60 centimetres may be too big to drink from. Question number 15. We've got figure 4 which shows a sketch of the curve C with equation y equals 5x to the power of 3 over 2 minus 9x plus 11, where x is greater or equal to 0. We've got P with coordinates 4, 15, which lies on C, so let's add this on. We've got 4, 15. And we've got the line L, which is a tangent to C at the point P. We've got this region R, which is bounded by the curve C, the line L and the y-axis. We have to show that the area of R is equal to 24, making a method clear. Well, we've got the word tangent here, so what we can do is find out the area of R. Before we do that, we need to find out the equation of the line L. We can first of all find the gradient. To find the gradient, I would have to differentiate y. So, dy over dx is equal to 15 x to the power of 1/2 divided by 2 minus 9. So if I consider this point P with coordinates for 15, dy over dx will equal 15 lots of 4 to the power of 1/2 over 2 minus 9, and if we work out what this is, we get 6. And so we can find the equation of the straight line. We'd have y minus 15 equals 6 lots of x minus 4 and so therefore y equals 6x minus 9. What we can now do is find out the area under C between 0 and P. So the area under C, that's equal to the integral from 0 to 4, because that's the x coordinate, of 5x to the power of 3 over 2 minus 9x plus 11 with respect to x. So let's work this out. Now we can't just use our calculator straight away, unfortunately, because it said solutions relying entirely on graphical methods are not acceptable. So we need to show our working out over here. Well, if I integrate 5x to the 3 over 2, I end up with 2x to the 5 over 2, and then I've got minus 9 over 2 x squared, the integral of minus 9x plus 11x. And what I need to do is evaluate all of this between 0 and 4. Now for the lower limit, I'm just going to get 0, so for the upper limit, I've got 2 lots of 4 to the power of 5 over 2 minus 9 over 2 lots of 4 squared plus 11 lots of 4. And for the lower limit, I've got 0 minus 0 plus 0. And it turns out here I get 36. That's the area under C. Now I can also find out the area under L between 0 and 4. So the area under L, that will equal the integral from 0 to 4 of 6x minus 9 dx. So if I work out what this is, I have 3x squared minus 9x between 0 and 4. So for the upper limit, I've got 3 lots of 4 squared minus 9 lots of 4. For the lower limit, I'll have 0 minus 0. And it turns out here, I'd get 12. And so the area of R is the difference between these. So therefore, the area of R is equal to 36 minus 12, which is 24 units squared. Question number 16, we have to express 1 over p lots of 11 minus 2p in partial fractions. So for part A of the question, we have 1 over p lots of 11 minus 2p, which we need to express in partial fractions. Well, this will be equivalent to a over p plus b over 11 minus 2p. And if I multiply through by p lots of 11 minus 2p, 1 is equivalent to a lots of 11 minus 2p plus b lots of p. Now we can substitute in different values of p to help us find out what a and b are. For example, when p equals 0, I've got 1 equals 11a, in which case you can see a is equal to 1 over 11. And when p is equal to 11 over 2, I've got 1 equals 11 over 2b, in which case you can see b is equal to 2 over 11. And knowing what the values of a and b are, we can now conclude that 1 over p lots of 11 minus 2p is equivalent to 1 over 11p plus 2 over 11 lots of 11 minus 2p. And that's exactly what we wanted to show. Now, a population of meerkats is being studied. The population is modelled by the differential equation dp over dt equals 1 over 22 lots of p lots of 11 minus 2p, where t is greater or equal to 0 and p is in between 0 and 5.5. And p in thousands is the population of meerkats, and t is the time measured in years since the study began. Given that there were 1,000 meerkats in the population when the study began, we have to determine the time taken in years for this population of meerkats to double. So, what we need to do is separate the variables here. And if we separate the variables for part B, we've got the integral of 22 over p lots of 11 minus 2p dp equals the integral of dt. And if I take out the 22 and replace the result here with this here, then I've got dp. This is equal to the integral of dt. And if I multiply the 22 inside the bracket, we've got the integral of 2 over p plus 4 over 11 minus 2p dp equaling the integral of dt. So if I integrate, I've got 2 times by the natural log of the mod of p minus 2 times by the natural log of the mod of 11 minus 2p, and this is equal to t plus c. Now when t equals 0, because I've got 1,000 and I know that p is representing thousands, p will equal 1. So I've got 2 times by the natural log of 1 minus 2 times by the natural log of 11 minus 2, which is 9, and this is equal to 0 plus c. So therefore, c is equal to minus 2 times by the natural log of 9, because the natural log of 1 is 0. And so you can see then we've got 2 times by the natural log of the mod of p minus 2 times by the natural log of 11 minus 2p equals t minus 2 times by the natural log of 9. Now what I want to do is find out what t is when p equals 2. The reason for that is because I want the population to double. That's 2,000 meerkats. So p is equal to 2 in that case. So when p equals 2, I've got 2 times by the natural log of 2 minus 2 times by the natural log of, well, 11 minus 4 is 7. And this is equal to t minus 2 times by the natural log of 9. So let's see what t is. I've got 2 times the natural log of 2 minus 2 times by the natural log of 7 plus 2 times by the natural log of 9, and it turns out we get 1.89 given to 3 significant figures. And now for part C of the question, we have to show that p equals a over b plus ce to the minus 1/2 t. Well, what we're going to do here is start off part C with this line here. And what we need to do is rearrange for t. So if I divide through by 2, I've got the natural log of p minus the natural log of 11 minus 2p equals t over 2 minus the natural log of 9. So t over 2 is equal to this is equal to the natural log of p minus the natural log of 11 minus 2p plus the natural log of 9. And if we use the addition law and subtraction law, t over 2 is equal to the natural log of 9p over 11 minus 2p. And if we anti-log both sides, e to the power of t over 2 will equal 9p divided by 11 minus 2p. And if I multiply through by 11 minus 2p, I would have 11 minus 2p lots of e to the power of t over 2 equals 9p. So, rearranging even further, I can see that 11 minus 2p over p equals 9 over e to the t over 2. And if I split this up on the left hand side, I have 11 over p minus 2, because I've got 2p divided by p, which is just 2. This is equal to 9 over e to the t over 2. So I've got 11 over p equals 9 over e to the power of t over 2 plus 2. Now what's my motivation of doing this? Well, if I look to the form we need to give our answer in, I've got an e to the minus 1/2 t. So what I can do here is rewrite this as 11 over p plus equals, rather, this is equal to 9e to the minus t over 2 plus 2. So if I rearrange and swap these over, I can therefore see that p, which is what I want to find, is equal to 11 over 9e to the minus t over 2 plus 2. So therefore a equals 11, b equals 2, and c equals 9.